Hello, welcome. Today we are here to see the question called Find the floor of a given number from the sorted array. So before we proceed, let's see what does this floor of a given numbers mean. So basically floor of a given number is like generally when we call about floor of a number, it is the least value, like the highest value which is less than the given number, the highest value. Okay, the highest value which is less than the given number. So if you take in this array, what is let's say value is equals to, let's say I give you as 1 7 17. Now if I want to find out floor for this number, what how I will find out? So basically floor means the highest highest value, okay, highest value which is less than given value, the highest value which is less than the given value. So what I'm saying is we need to find out the highest value only, but this highest value should be less than given value. Okay, now, okay, in this example what is the value? So let's say if you take 19, this is the highest value only obviously, but is this less than 17? No, this is not an answer. Let's take 8. No, this is also one of the highest value, but is this less than 17? Yes. Yes. So answer would be 8. We need to find out highest value, the bigger value from the given array, but the value should be less than given value. The value should be less than given value. So what is the given value? Given value is 17. Given value is, what is the given value, guys? 17. Let me draw that. Given value is 17. Now, so how we will do this? How we will do this? General approach, like the basic approach, how we will do. So what I do, I know what is the floor means. What is the floor means? So it is the highest value which is less than the given value. So by default, let's take one answer variable. Answer. By default, I don't know the answer. By default, I don't know the answer. So I'll make it as -1. By default, it will be -1. So this indicates this array doesn't contain the answer. Okay, we'll come back to this later again. Just we'll come back to this later. So let's say by default, we don't have any answer. Now I'll go to the first element of the array. What is the element? What is the element? Element is 4. The element is 4. Is this 4 less than 17? Obviously, we highest value, it can any value, every value is highest value. Okay, every value is highest value, but it should be the less than the given value. So first thing, is it less than 17? Obviously, yes. So this can be my answer. Let me update this with 4. That can be my answer, right? That there is a possibility this can be my answer. Okay, I'll update it. Now I'll go to the next element. What is the next element? It is 7. Okay, I'll 7. Okay. So is this 7 less than 17? Obviously less than 17. So I'll update my answer. You can think, you can have a question in your mind. Why we are directly updating? Why we are directly updating? Aren't we check? Why are we not checking with the existing value? Why we are not checking is there are two reasons, guys. There are two reasons. First reason is we need highest value. We need highest value. Sir, you can ask me, sir, how we can say this is the highest value, not 4? Because we are coming from left to right and array is in sorted fashion. Array is in sorted fashion. This is the second reason. And the first reason is we are searching for highest value. And we are coming from left to right. Left to right. Okay, is this clear, guys? Now I'll go to the next element. Now I will go to the next element. What is the next element? It is 8. Next element is 8. Is this less than 17? Is this less than 17? Obviously correct. So I'll update this value. Why I'm directly updating, guys? Why I'm directly updating? Because we are coming from left to right and the array is already in sorted order and our main goal is to find highest value from the array. Highest value from the array. Okay, now my answer is updated with 8. Okay, what is the next value, guys? What is the next value? Next value is 19. Next value is 19. Is this 19? Is this 19 less than 17? Less than 17? No, right? Obviously, no. 19 is always greater than 17. So this is not my answer. And this is not my answer. I know that this is not my answer. Now you guys say me, is it necessary to check on the right side? Is it necessary to check on the right side? Guys, come on, answer. Is it necessary to check on the right side? Do you think? Yes or no? No. Why? Why we should not check on the right side? Why we need to stop it here itself? Because, because again the same reasons, guys. Array is in sorted order, which means if this is not less than, obviously all the elements on the right side are not less than. That is true, right? We know how this sorting works. All the elements which are on the right side of 19 are greater elements. Are greater elements. So this obviously 19 is not satisfying the condition. Obviously, the remaining elements will also not satisfy the conditions. Will not satisfy the conditions. So this is what the intuition, guys. This is what the intuition that we have. So we will go on one by one element, one by one element, one by one element, one by one element. Every time what we will do, I will check whether this is my is this value less than 17? Is this value less than 17? Which means given value. If it is true, update the answer. Update the answer. Is that clear, guys? Is that clear? So let me write down the steps. Let me write down the steps. What is the first step? Iterate on array. Iterate on array. Okay, I am iterating. While iterating, what I need to do? What I need to do? Check current value in array is less than given value, less than given value. Check, we need to check, we need to check if this is true. If the above condition is true, if the above condition is true, what I need to do, what I need to do, guys, what we need to do, if the above condition is true, if the above condition is true, update update the current value as answer. Update the current value as answer. Update the current value as answer. What if the condition is false? What if the condition is false? Okay, what we need to do, if the condition is false, stop iterating and print answer. Stop iterating, which means what we need to do, how we can stop the iteration? Break. That's all simple. Take a break and just come out of the loop and print the answer. Print the answer, which is stored in ANS variable. ANS variable. I hope this is clear, guys. If not, just pause it for a second and listen carefully. We are searching for, we are finding the floor of a given number. What is the floor of a given number? Highest value which is less than given value. Highest value which is less than given value. Okay. So we need to find out the maximum value from the array. From this entire array, we need to find out the max value. But this max value is there now. This should be less than 17. Less than 17. That's what the question is. I hope this approach is clear. This approach is clear and everything is clear. So let me take another n value, guys. Let me take another n value. Let's not take 17. Now let me take 1. 1. 1. I'll go to this array. I'll go to this array. What is the first element I have? 4. Is 4 less than 1? Obviously, condition itself is true. If condition is false, what we need to do? Stop iterating and print the answer. I will stop iterating. I'll come out of my loop. What is the answer? Do we have an answer? Do we have an answer? No, right? We don't have an answer to print. So in this cases, what we need to do? In this cases, what we need to do? So when we are initializing our answer variable, when we are initializing our answer variable now, we need to initialize that with -1, -1. So this indicates if answer is not there from the array, it will print -1. If the answer is not there from the array, it will print -1. What -1 indicates? It indicates there is no answer. That's all. That's all, guys. There is no answer. That's what it indicates. I hope this is clear. So let's jump into the next thing. So what is the time complexity, guys? What is the time complexity? What is the time complexity? Obviously, the time complexity is less. What is the time complexity? It will be big O of, it will be big O of n. It will be big O of n. Sir, why n? Because in the worst case, I need to iterate on the entire array. I need to iterate on the entire array. So that is the reason the time complexity is big O of 1. Big O of 1. So is there any better approach than this? Is there any better approach? If you observe, the array is already sorted. The array is already sorted. Okay, already sorted array. Now, in this sorted array, are there anything that we can use to reduce this n? To reduce this n, guys? To reduce this n, is there any possible technique that you can think of? Try to think, just pause for a second, pause the video for a second, and think, is there any way to solve this? Is there any way? Okay, so I hope you have paused the video and did that. If not, let's see what actually we can do. So I'll also give you one more clue, guys. The time complexity will be reduced to log n. Time complexity will be reduced to log n. This will be your time complexity for the optimized one. Optimized one I'm talking about. I'm talking about optimized one. So pause the video again. Just think of this one. Okay. I hope you have paused it for a second and I've thought, give it a thought. So if not, let's see it now. If not, let's see it now. So if you think, what is the algorithm or where we have this log and time complexity, guys? Where we have this log and time complexity basically. So we have this log and time complexity for binary search. Binary search. I hope you remember this binary search, guys. Don't. Okay. Binary search algorithm. Binary search algorithm. In binary search algorithm, we have time complexity of how much? How much time complexity we have, guys? It sorry. Okay, sorry. So in binary search, it takes time complexity of log n. Log n. Log n, guys. Okay, so this is the technique that we are going to use. This is the technique that we are going to use to solve this particular question. Okay, you can ask me, sir, how this can be implemented? How we can integrate this binary search? It is a searching technique. It is used to search for a number. But now we are here, even doing the same thing. We are searching for the number, but the number should follow this particular rule. The number should follow this particular rule. It should be the highest value and it should be less than the given value, less than the given value. So let's proceed. Let's dive into that particular approach, guys. Let's do that now. So let me scroll down. Yes. So let me take the array 4, 5, 7, 8, 19, 20, 25. Okay. Okay. These are the values, guys. Now. Okay. I hope this is clear. So this is the place where I will start. Okay, this is your zeroth index. Okay. Now, what is a binary search? How your binary search works? There will be a low, which will be pointing to initial value will be 0, and there will be a high where the initial value will be length minus 1, which is 4, 6. Length minus 1, 6. Okay. So before you see this code and all, before you iterate through code and all, I'll help you to understand how this approach works here. So now you guys think, now you guys tell me, let's say we are searching for something called as 7. No, not 7. Let's say we are searching for something called as 3. Okay, we are searching for something called as 3. Now, when I'm using binary search, how binary search works, it will land in the middle element. It will land on the middle element. Now, when I was at this position, when I was at this position, I am searching for three, right? I'm searching for three. Now, you guys see me. This element matches with 3? Obviously, no. Now, which side I need to check for? Which side I need to check for? Obviously, on the left side. Why on the left side? If because the elements on the right side are greater values. The elements on the right side are greater values. How we are saying greater values? Because the current element 8 itself is the greater value than 3. Okay, 8 itself is greater than 3. So even though if we search on the right side, we don't get an answer here. We don't get an answer. So we will see on the left half of the array. We will see on the left half of the array. If you observe here, I don't have any answer. We don't have any element called 3, but still we can figure out that we can identify that. Okay, what we can identify when I was at this position and I'm searching for 3, I can identify even though the array doesn't contain this element, what I can identify here is I can break down this array. I can break down this array after first iteration itself. Let's say I have 100 elements which I'm searching for. Okay, after landing on the middle element, I know I need to just search on the left side. I need to just search on the left side. Then it got reduced to how much, guys? It got reduced to 50. It got reduced to 50 elements. So in this way, this will help us to search only on the necessary side. Search only on the necessary side. And when searching, we will also try to find out the floor. We will also try to find out the floor. How we will find out the floor? Let's see that now. Let's see that now. What is the value that we have taken, guys, as an input? So value that we have taken as input is 17. So what is the answer for this 17, guys? What is the answer basically? What is the answer? Answer is 8. Answer is 8. Okay. Now, this is our answer. Anyways, we know this answer because of the above approach that we did. Now we need to, so we will use binary search. We will use binary search. So initially, what is the value of L? What is the value of L, guys? L value will be 0. So let's take the indexes 0, 1, 2, 3, 4, and 5, and also 6. So L value is 0. R value is, let's take it as a right, guys. R value is 6. Now, what is the first step that we will do? We will calculate for the mid. What will be the value of mid? Mid value will be 3. Mid value will be 3. What is the element that is present at index 3? What is the element that is present at index 3? Element present at index 3 is 8. Element present at index 3 is 8. 8 is the element. Okay. What we are trying to find out? Floor of 17. Floor of, what we are trying to find out? Floor of 17. So what does floor means, guys? Highest value. Highest value. Okay. Let me write just as high. Highest value which is less than given value. Highest value which is less than given value. Now when you are trying for the floor of 17, we are landed on 8. What I can conclude here? What I can conclude here? You guys think. So when we are on 8, is this 8 less than 17? Is this 8 less than 17? Obviously, this condition is true. So when this condition is true, what we can say, this can be a potential answer. This can be a potential answer. This is not our answer, guys. This is not our answer at the end. This can be an answer. Okay, this can be an answer. So what we will do, we will take one answer variable called a, which will be updated with 8, which will be updated with 8. Okay, which will be updated with 8. Now you guys think. Okay. Okay, let's not take 17. I think this exactly landed on the R element. Let's take something called 23. 23. What will be the answer for 23? Let's see via code itself. Okay. 23 is the variable. Okay. Okay. Now we are searching for 28. Okay. Not f of 17. It will be f of 23. F of 23. Now we are searching for floor of 23. Now we are landed on value 8. Is this 8 less than 23? Is this 8 less than 23? Obviously, this condition is true, right? So this 8 can be a potential answer. So our goal is to find out a value less than given value, and it should be the highest value from the array. It should be the highest value from the array. So this can be an answer. 8 can be an answer. So I'll update my answer variable with 8. Okay. Okay. Now you guys say me which side I need to search for. Should I search on the right side or left side? You guys say me. Which side I need to search? Which side, guys? Yeah, correct. We need to search on the right side. Why we need to search on the right side? Because we are finding for the highest value. What we are finding for? We are finding for the highest value. Okay, highest value that should be less than, that should be less than given value. We are searching for the highest value, which is less than the given value. What we are searching for, guys? We are searching for the highest value. We are searching for the highest value. That should be less than, that should be less than given value. Okay. So if I go on the left side, if I go on the left side, obviously I'll find out the values which are less than given value. But are these values the highest values? No, right? These values are not even greater than 8. So I can't, there is no point of checking on the left side. I need to search on the right side. So I will store 8 as in my answer. I will search on the right side. Now, what is the value of L will become? It will become 4. It will become 4 because L equals to M plus 1. L equals to M plus 1. It will become 4. Now, what will be the value of mid? Value of mid? Value of mid will become 5. Value of mid will become 5. What is the value at index 5? What is the value at index 5? It is 20. It is 20. Is this 20? Is this 20? Okay, is this 20 less than 23? Is this 20 less than 23? Obviously correct. Obviously correct. So I'll update this as my answer. I'll update this as my answer to 20. 20. I'll update this as my answer to 20. Now you guys say me. I have updated. Which side I need to check again? Should I search on the right side or on the left side? Which side, guys? I need to search only on the right side. I need to search only on the right side because already these values, this value is less than 20, There is no point of searching. We are finding for the highest. So I'll search on the right side again. Now, what is the value of L, guys? It will become 6. It will become 6. What is the M value? M value will become 6. What is the value at index 6? Value at index 6 is 25. Is this 25? Is this 25 less than 23? Is this 25 less than 23? No, this condition is not at all true. That condition is not at all true. Should I search on the right side again anymore? No, I don't have any elements, but I'll also not search on the right side because the elements on the right side, let's say we have 27, 27, 29 on the right side. Now, will you search on the right side for the lesser value? No, right? Of this 25 itself is not less than 23. So these elements will also be not less than 23. So I'll not search on the right side. I'll search on the left side. I'll search on the left side. So this L value will be up, right value will be updated to 5. Now this will stop working. With this will stop iterating. Why? Because we know the condition of while loop. L less than or equal to R. This is our binary search while loop condition, right? So the same applicables here. The same applicable here. So only change here is if we find an element which is less than or equal to given value, then this can be a potential answer and we will search on the right side. We will search on the right side. I hope this is clear. Let me give you the steps and let's see. Okay. Okay. What is the first step, guys? What is the first step? We know we need to, we have only three things, guys. So we will calculate mid. We will calculate mid. I'm directly jumping into this step, guys, because we know the basic binary search logic. Everyone knows this. I'm directly jumping into this one. We'll calculate mid. After calculating mid, what we need to do? Check for value at mid index. Okay, check for value at mid index. So what I said when I say mid index, it is nothing but uh, nums of mid. Okay, if this value is okay, if this value is lesser than lesser than or equal to given value, if it is lesser than or equal to given value, what I can say, guys, what I can say, if it is less than or equal to given value, then update it to answer and right side search on right side. Okay, if it is greater if it is greater, search on right sorry search on left side at the end, return return the answer. That's all, guys. That's all. Pretty simple one. So what we are doing is we are calculating the mid as we did previously. Okay, as we did, we are calculating the mid, and after that we will calculate the mid index. Like, we'll check for the value. Mid index is nothing but, let's say if mid is 3, we'll go to this index and this value. And if the value is lesser than or equal to given value, so given value is 17 in our case. So if this value is less than 17, update it to answer. So update it to answer. So answer will become 8. This is the value, guys. If you want index, answer index, it will be 3. Like, this is the index of the answer. This is the actual value. Yeah, that's what. And that's all. Here itself, it is okay. Value is lesser than or equal to a given value, update it to answer. Okay. After updating to answer, search on the right side. So I'll search on this part. But again, I'll calculate mid. I'll land on this one. And 20 is not less than 17, which means if it is greater, if the 20 is greater than 17, which means not less than, it is greater than, obviously it is not less than 17. So search on the left side. I'll search on the left side. I only have one value here. This will be 19, and this is also not less than 17. And obviously I'll search on the left side again. And now my left and right will converge here, and I will stop my process. Answer will be 8. Answer index will be 3. That's all. So let's jump into code. Let's code this, guys. Okay, these are the numbers. This is the value. So now int L equals to 0, R equals to nums dot length minus 1. Okay, comma M. Int answer equal to minus 1. Index. Okay, answer index equal to minus 1. So what does this answer index will become is, what is the index of this particular answer value? It will return. So, okay, fine. So while L less than or equal to R, yeah, M will calculate M. What is the first step? Calculate the value of M. M equal to L plus R by 2. Okay, after calculating, if my nums of M is less than or equal to given value. What is the given value? 17. If it is true, what I need to do? Update the answer. Answer will be nums of M. What is the answer index? What is the answer index? It will be M. After that, which side I need to search on? I need to search on the right side, which means L will be moving to M plus 1. Okay. When we need to search on the right side, my left pointer is here, right pointer is here. I need to search on the left side. So my left pointer will move to this. Okay. Now L will be moving to M plus 1. Else, Else, obviously, if it is less than or equal to, it will go here. If it is not less than or equal to, which means obviously greater than. That's why I'm not writing the condition here. Else, I'll search on the left side, r equal to m minus 1, m minus 1. That's all. And after this entire for loop, we'll simply print system dot out dot print line println answer. Answer index. Okay. Now let me run this. You can see answer is 8. What is index of answer is 2. You can see this is 2. So let me give one more value. Let's give 23, guys. What will be the answer? For 23, it will be 20. And the index of 20 is 0, 1, 2, 3, 4. Let's see. Answer is 20. Answer's index is 4. I hope this code is clear. Pretty sure whatever the while loop logic that we have for binaries is the same. Only slight modification is done here. That's all, guys. I hope you enjoyed the video. Thank you.